Yes.
Okay, perfect. Hi guys, I'm teacher E from LingualBuzz. So welcome to this live class co-hosted by LingualBuzz and Create and Learn. I'm teacher E and I have been teaching Chinese on LingualBuzz for over 3 years. LingualBuzz was founded in 2017 and it is devoted to providing high-quality Mandarin education to children aged from 4 to 15 all around the world. Now we have 80,000 students from 108 countries and regions, and also we are a partner of over 50 dual language immersion schools. So if you are interested in learning more about Mandarin, please feel free to contact us and you will get free demo lessons at the end of the class. So today we're going to have fun and spend this hour on learning the story of the invention of Chinese characters and also how computers display languages nowadays. Are you ready? Thumb up if you're ready. Great. So today's learning objectives. First, we will learn a story about how Chinese characters were created. And then we will learn a few simple Chinese characters. First question, do you know the name of the person who created Chinese characters? If you have an answer, you can type your answer in the chat box. The name of the person who created Chinese characters. Any ideas? You know, in our lives, many things were invented and created by our ancestors, including writing system, both English and Chinese. No worries. So it is said the man called Cang Jie, you can look at the screen, this man called Cang Jie, his name is Cang Jie, he created Chinese characters. Great job, someone knew the answer. Yes, it's Cang Jie. He created Chinese characters, and today we're going to read a story to learn about how did he create Chinese characters, and do the Chinese characters he created thousands of years ago still look the same today? So please keep these two questions in your mind. How did he create Chinese characters, and do the characters he created thousands of years ago still look the same today? And we're going to find answers to these questions. Ojeda says, my mom, your mom was born in China but doesn't know. No worries, we're going to read this story together and you will get the answer. Our story starts a long time ago when there were no written words in the world. Guys, let's look at this picture and look at how the people, what people wore and what they ate. Could you please tell me what's the difference between their lives and our lives today? You can think about the food they ate, how they got food. Kelsey says they use animal skins. Yes, in ancient times, people wore the furs of the animals. Amia says the kid is helping doing something. Could you please tell me more and what is he doing? What is the kid doing? Ah, great, the woman has a tooth necklace. Yes, they didn't wear shoes. They don't have the big house, they lived in the small tents. They used to hunt. Great points, guys. All right, now let's look at the kid on the left. Could you please tell me what is he doing? What is he doing? Knots, tying knots, right. Why is he tying knots? Ah, Kelsey got it. The boys remember things. Yes, in ancient times, there was no written language, no writing system. So people tied knots to record the important things happen in their lives. Let's go and see what happened. One day, two important things happened. On the left, there was a big battle, and a young man caught a fish. Now you know they tied knot to remember important things in their lives. Now let's look at the knots on the left and on the right. Could you please tell me what is the difference between two knots? And difference, you can share your thoughts in the chat box. What's the difference between two knots? They tie differently, true. Great, one is bigger. Left one looks more crazy. Okay, yeah, you guys got it. The one on the left is bigger than the one on the right. And do you know why? Why the left one is bigger? Amia says because the left knot is more significant, and we can see that the event they wanted to record is more important than the one on the right. Great job, guys. Now we learn that ancient Chinese people tied knots to remember events. Here comes a question. Can you think of any problems with using knots to remember things? Imagine if you are going to use knots to remember or record the things happen in your life instead of writing diary. What might be the problems? What might be the problems if you use knots to remember things? Oh, Sid says you never know which one is for which. Yeah. Emma says it's long and hard to understand, hard to remember, right? Oh, the knots could break. That's a good point too. Let's see what the story says. There were so many problems with using knots to take notes. Over time, people forgot what the knots meant, but they couldn't think of a better way. Look at these people. Can you have a guess what they were talking about? They kind of looked confused. What were they confusing about? It seemed that they were trying to figure out what the knots meant. Yes, Amir, you're right. They don't remember which one is for which event. So a man named Cang Jie wanted to create a new way to help people remember things. Cang Jie thought about it day and night. Let's look at Cang Jie's face. Can you use one word to describe how Cang Jie felt now? Sid says, sad. Yes, Cang Jie looks sad. And different words, confused, bored, maybe. Yeah, depressed, confused, sad, or upset, disappointed. Yes, Lauren says frustrated. Good thoughts, guys. Because it was not easy to invent a new way of recording things in ancient times. But one day they were chasing a tiger. Cang Jie saw the tiger's footprints on the ground. Suddenly, he had an idea. What is Cang Jie looking at? What is Cang Jie looking at? Footprints. Yes, a footprint from tiger. And can you have a guess what's the Cang Jie's idea that is related to recording something? To draw what happened in their lives. Great points, guys. Cang Jie thought tiger's footprints told us where a tiger was. Maybe we can use a drawing of tiger's footprints to remember a tiger. What else can we draw to remember things? Let's look at this picture. What else did Changjie think about? Good point, Jacob. Jacob says make a word like a little drawing. Yeah, Lawrence says sun, the moon, the water. Yeah, E says water, and mountains. So look at these symbols. These simple symbols are the characters in ancient China, and people used these symbols to record or remember or represent objects in their lives. Great, a word like a basic drawing of symbols. Got it. Now it's practice time. Let's look at the left column. There are 3 objects: tiger, sun, and mountains. And on the right column, there are 3 symbols, or can see 3 ancient Chinese characters. Can you match the objects with the ancient Chinese characters? And let's start from the first one, tiger. You can type the number 1, 2, 3. Which one is for tiger? Great, number 2, the tiger's footprint. Yes. And the number 2, the sun. Yes, like a circle with 1 dot in the middle. Great job, guys. And the last one, mountains. Yeah, the right answer is number 1st. Look like mountains. I found some of you know how to see them in Chinese. So the sun in Chinese is 日, and the Chinese for mountains is 山. Amia knew the answer. Great. Okay, let's keep going. Changjie created many characters, but he was the only one who knew what they meant. What did he do? Changjie told the people around him in his community, and everyone liked this way. Look at this picture. Changjie was teaching the people in his community how to use the symbols, use the little drawings to represent things, to record the things. Now the new method had been figured out. Let's see whether it's easier for people to use it in their lives. Good news. Over time, people started to use Changjie's characters. Let's look at the pictures on the top. Could you please tell me what did Changjie write down on the top? What did Changjie write down? You can find the answer from the picture beside it. Yes, Aliyah says, hunting. Most of you got it. Yet it means hunting. They went for hunting. Great. 打猎. Yes, in China, hunting in Chinese is 打猎. Right. All right, now let's see the picture or the Asian Chinese characters on the bottom. Do you know what did Changjie write down? There are 2 men. Yes, they are leading a bull. They are leading a bull. Feeding is also a good guess, but the right answer is they are leading the bull. Great. Yeah, they're leading the bull. So now you know in ancient China, people use the little drawings and the little symbol of the symbols of the objects to record what happened in their lives. And this is where Chinese characters came from. On this picture, you see the current Chinese character. Do you know which character is it? Yes, it's the sun in Chinese is 日. And did you still remember what did Changjie draw? Are they the same? What did Changjie draw for sun? Yes, a circle with a dot in the middle, just like this. So many Chinese characters, they were originated from the pictures. They are pictograph. And in ancient times, people wrote down the Chinese characters on the oracle bones. Yeah, so circle with a dot in the middle. You guys got it. Now it's practice time. Let's look at this page. There are 4 ancient Chinese characters on this page. Could you have a guess what they mean? Let's start with the first one. Now you know most Chinese characters are pictograph. So think about what it looks like. Yes, it's river, 水, water, 水, 水. Great. And how about the second one on the right? Oh, someone says it's like a penguin. It's a good guess, but it's not a penguin. Yes, it's bird. Lobster, a good guess too. It's a bird, and the bird in Chinese is 鸟. 鸟. I'm going to type the character 鸟 in the chat box. 鸟. It's what it looks like nowadays. 鸟. How about the third one? We have talked about it. And do you remember how to say it in Chinese? Mimi knew. It's 日. 日. Yeah, also means 太阳. 日. How about last one, number 4? Yes, it's mountains. Do you know how to say mountains in Chinese? Or can you type the Chinese characters in the chat box? Great. It's 山. 山. Great job, guys. All right. So nowadays, in addition to Chinese characters, we also have emojis to send messages to each other. And now let's look at the picture. Can you have a guess what this emoji sentence means? How about the first one? The first one. A man, an eye, a cat, a car, and sleep. What does the first emoji sentence say? A man sees a car in a car. How about the last sleep? Oh, someone says a guy says a sleeping cat in the car. Good guess. Different ideas. Right. The right answer is a man saw a cat sleeping in a car. How about the second one? Man drops kid at school. Good guess. Yes, or dad and son, they drove to school, right? You guys good at emojis. Let's try more about Chinese characters before we go. So on this picture, you saw 5 pictures. 5 pictures. So let's start from the left. By looking at the picture, could you please tell me what does the first character mean? Or the more challenging question, how do you know how to say it in Chinese? Or can you type the Chinese characters? Yeah, it means rock or stone. And do you know how to type it in Chinese? Shi, yes, it's shi, and I'm going to type this character in the chat box. Shi, shi. Oh, it's not she, it's shi, shi, just like number 10. It sounds the same as number 10, shi. Great. How about the second one? What does the second one mean? Fire. And does anyone know how to say fire in Chinese? Good guess. It's 火. 火. And do you know how? Joy knows how to type it in Chinese. It's 火, 火, fire. How about the third one? Oh, good guess. Laughter. Yeah, Joy, you are right. 人, people means people. Yeah, he is laughing, but this character is people. 人. Do you know how to type 人 in Chinese? Great job, Cindy. Yes, it's 人. How about the next one? The one besides 人? It's tree. Do you know how to say tree in Chinese? 树. Good job, Jacob. 树. Yes, or we can say it's 木. 木, wood, which also means tree. 木. The last one. Who knows the answer? The last one. Yes, water. 水. 水. I also typed the Chinese characters in the chat box. 水. Great. Okay, guys, before we go, let's go back to our 2 questions I asked at the beginning of the class. So how did Cangjie create Chinese characters? You can type your answer in the chat box. How did Cangjie create Chinese characters? Yes, he made representations of them with drawings. Yeah, he drew what they look like in their lives. Great. And the second question, do the characters Cangjie created still look the same today? The Asian Chinese characters and the characters nowadays, do they look the same? They do look similar, but not exactly the same. They are different. Yeah, so the Asian Chinese characters, they are more like a picture, a little drawing, right? Great, thank you so much for your participation, guys. All right, so far you have learned how the Chinese character where the Chinese character came from and who created Chinese characters. Now you're going to learn a new language. Do you know that computers also have their own languages? Like what kind of computer languages do you know? Coding, yes. Like Scratch. My little brother was learning Scratch, yeah, Python. Great. And next, let's welcome the teacher Jamila from Create and Learn, and she's going to teach you guys language used in computer system. Thank you, guys. Thank you so much. And now I'm going to hand it over to you, Jamila.
Okay, thanks. Hi, guys. So I'm going to share my screen now. And yeah, so we're going to learn about languages in computers. So I saw how in the chat, a lot of you seem to know a lot about different languages in the computer already. So we're going to look at some of the different ways that a computer actually communicates with itself as well as with other people, and how we can actually communicate with the computer to get it to do what we want it to do. So we will start by first looking at the fact that everything in a computer is nothing but ones and zeros. I saw some people in the chat had actually mentioned that computers are, everything in the computer is ones and zeros. The text that you're typing in the chat right now, the images that you see on the screen, ultimately the computer understands those as ones and zeros. So let's look really quick at how that works.
Hi, my name is Lamore Free, and I'm an engineer here at Adafruit Industries. And this is where I do engineering and design, and I design circuits for fashion and music and technology.
My name is Federico Gomez Suarez, and I'm a software developer with Microsoft Hack for Good. And I look into using technology to help us solve some of the big social problems of our times.
You may have heard that computers work on ones and zeros. Or you may have seen scary-looking visuals like this. But almost nobody today actually deals directly with these ones and zeros. But ones and zeros do play a big role in how computers work on the inside.
Inside a computer are electric wires and circuits that carry all the information in a computer. How do you store or represent information using electricity?
Well, if you have a single wire with electricity flowing through it, the signal can either be on or off. That's not a lot of choices, but it's a really important start. With one wire, we can represent a yes or a no, true or false, a 1 or a 0, or anything else with only two options. This on-off state of a single wire is called a bit, and it's the smallest piece of information a computer can store. If you use more wires, you get more bits. More ones and zeros, with more bits, you can represent more complex information. But to understand that, we need to learn about something called the binary number system.
In the decimal number system, we have 10 digits from 0 to 9, and that's how we've all learned to count. In the binary number system, we only have 2 digits, 0 and 1. With these 2 digits, we can count up to any number. Here's how this works. In the decimal number system we're all used to, each position in a number has a different value. There's the 1 position, the 10 position, the 100 position, and so on. For example, a 9 in the 100 position is a 900. In binary, each position also carries a value, but instead of multiplying by 10 each time, we multiply by 2. So there's the 1's position, the 2's position, the 4's position, the 8's position, and so on. For example, the number 9 in binary is 1001.
Notice that here, we're adding up only the ones that have a 1 in them. So we have the 8 plus the 1, and that's giving us 9. So I'm going to watch just a few more seconds, and then we're going to actually try this out.
To calculate the value, we add 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. Almost nobody does this math because computers do it for us. What's important is that any number can be represented with only ones and zeros, or by a bunch of wires that are on or off. The more wires you use, the larger the numbers you can store.
With 8 wires, you can store numbers between 0 and 255. That's 8 ones. With just 32 wires, you can store all the way from 0 to over 4 billion. Using the binary number system, you can represent any number you like. But what about...
Okay, so she's about to start talking about images and videos, but we'll get into that in a second. So let's actually try this out first. So this game I'm putting in the chat lets you actually try out how to count in binary. So when you pull up that link, it's going to take you here. You can click to try it. And what you see is there's 2 ways to play this game, and it's going to keep piling up on me if I don't do it fast enough. So I'm trying to add up. So any of the ones that don't have a number here, it's telling me to put in what the total is. So here I see there's only a 1 in the 2 place. So I'm going to put a 2 there, and I get it right, and it goes away. This one says 13. So I need to put ones in enough places to get 13. So I'm going to try, oh, I lost. So here I've got 16. So I do 16. This one gives me 1. Here I'm trying to add up 8. That one's right there. Then I have 8 plus 4. What's 8 plus 4, guys? 12, okay, and then plus 1, so I can put 13. What's this bottom one? 4 plus 1, 5. Someone's telling me. Okay, how do I get 7? Oh, I didn't do it fast enough. All right, let's try one more. And if you're playing on your own, that's fine too. Yeah, I could have done the 4, the 2, and the 1 for 7. Look, I got 7 again. 4, 2, 1. That one goes away. This one, I just have a 1 in there. This one, all of them are 0, so that's just 0. It won't let you play. Well, that's weird if it won't let you play, but let's see. You clicked try it. Yeah, if it won't let you play, that's okay. Maybe it'll let you play another time. But that's how we do that. So that's how, you know, we're able to play in binary and try that out. So binary also lets me, so we saw how we can do binary with numbers. Binary also lets me represent text in different ways. Of course, the way that text is expanded, we've also had to expand the ways that we can represent that. So we're going to take a look at this video that's actually going to show us some additional, somebody's drawing on the thing, some additional ways that we can do this.
We already know how to convert ordinary decimal numbers into binary code. We simply take the 8 place value columns for the binary table, identify which of those numbers we need in order to add up to the total, in this case of 182, and then put 1s under each of those numbers, filling the remaining columns with 0s. But how can we do the same thing for letters? We understand numbers can become numbers, but how do we turn letters into binary numbers? Every single key on your keyboard has a number associated with it. Every single character that you can type can be translated into a decimal number. For example, the character capital A on your keyboards becomes the number 65. This is a standard and is globally recognized. It's part of the ASCII table. Every letter, every symbol, and every number on your keyboard has a corresponding.
So notice on this table, this ASCII table, so ASCII is one way that you can represent or that computers understand how to read text. So what we see here is like the letter A is actually 65 in ASCII, which then we would convert that, the computer converts that into a bunch of 1s and 0s in order to understand what that means. So let's keep looking. There's some more ways that we can do this.
Corresponding number associated with it. So A is always 65. ASCII uses 7 bits. In other words, the binary numbers representing these letters have 7 bits to them. So we use these 7 columns to create a possible 127 different numbers, each of which has a number, letter, or symbol associated with it.
Now, when you think about that, so we saw how much you could represent, but really when you think about all of the different languages in the world and all the different characters and symbols that we use in the world, even like the Chinese characters that she was just talking about, that's not enough space for us to represent all of that. So then fast forward a little bit, we had to come up with another way to represent the additional languages and characters and symbols that we could do.
Characters seem fine, they fall far short of the number of characters that we often need to represent. These languages, for example, are not represented in standard ASCII. So how can we represent all these different characters and symbols, as well as the wide range of emojis, or whatever you like to call them? The answer is that we use Unicode. Now, Unicode is exactly the same thing as ASCII for all of the characters 0 to 127. But Unicode can use more bits than ASCII, and so it can represent a wider range of different symbols. So it can include all of the alphabets, a much wider range of symbols, as well as a wide and growing range of emojis.
So I see a couple of people have found some of the Unicode emojis in their chat. Can you, so when we look at Unicode, so just kind of going forward just a little bit more, so we see that we can actually represent a lot more information because of the fact that it holds 32 bits rather than just the 8 bits that ASCII did. So that's why we're able to do these emojis that you guys are putting in the chat in order to do that. So let's try, hopefully this one works for y'all. So this link that I just put in the chat is going to take you to this ASCII table. So that way you can see all of the binary numbers that correlate with the letters. So when you're looking at this, you see that here's the letter A right here at 65, the letter B at 66, but we also see the binary number right in between. So this message that I have on the screen, let's see if you can decode what this message is. I'll give you a couple minutes. I'll help you find the first letter. So I'm looking for 0, 1, 0, 0, 1, 0, 0, 1. So if I look at this chart, see that actually matches up with the letter I. Yeah, it is pretty hard when you do it this way. And luckily our computers can do it for us. Keep trying and see how much you can get before I tell you the answer. All right, so it looks like we're seeing why we're grateful for computers. So this message actually comes out to I love coding. So if I were to go and match up all of these binary numbers to this table, then I would find the that this first group is the letter I, the next group is the letter L, the next group is the letter O, and so forth. But we saw how really hard that was, right? Trying to figure out all of these individual binary numbers and correlating those with the actual letters. So when we think about that, that means that we really need an easier way to communicate with computers in order to get them to do what we want them to do. Okay, so in the chat, you just saw an example of this, but let's see if you remember what it was called. Which one do you think computers use to handle letters and characters from other languages? Is it ASCII or Unicode? Very good. Unicode. Good job. Unicode. Unicode lets us use or represent all the other languages and emojis and all that other stuff because ASCII can't do it. So you can also, if you're curious, this link that I'm putting in the chat will actually give you all of the entire Unicode table for a whole bunch of languages. You're going to see a whole lot of languages here, but if you click here where it says emoji, you can also see all of the Unicode for emojis. So this is how computers read these different emojis. So you can find those there. You can kind of play around with those. And then when you click them, it'll also tell you how to use them in other computer languages. So very cool. Okay, well, what about, so that was, we saw how numbers are represented. We saw how computers translate text, but how does a computer understand what to do with images and videos? So images and videos are broken down also to a bunch of ones and zeros. So that way the computer can understand them. These ones and zeros typically translate to pixels, which is really the smallest square of an image that you can possibly find. So you can even take like any picture that you take on your phone. If you zoom in enough, you'll start to see little squares in the images. Those are pixels. Hopefully this link works, but you can actually try it on that link that I put in the chat. You can close out the video. And so this actually lets you make kind of your own pixel art. And again, to a computer, it's a bunch of ones and zeros. So let's say I want to make an image. We'll just start by 10 by 10. So 1 is going to give me white. 0 is going to give me black. So if I do this, and then if I keep going, it starts going to the next line. And so I can keep putting a bunch of ones and zeros to try to make something like the smiley face that I had on the screen. Once you do that, if you click on actual size, it's going to show you how big that picture actually is. But we're zoomed in a lot so we can see these individual pixels. So let's see what you guys can make. Take a couple of minutes and see if you can make an image with that using ones and zeros. I'm going to see if I can remake my, you did it? Put your ones and zeros in the chat and I'll post it in mine. The link was in the chat. I'll post it again. Once you make something, if you want to put your code in the chat, I'll put it in mine. Ah, very cool. Let's see if I can make my smiley face again. Oops. Another row of ones. And then I had 1, 1, 1, 0. Y'all like my smiley face? Oops. Anyways. All right. So if you're playing around with that, does anybody else want to share their ones and zeros? Gavin shared some. Let's see what Gavin made. Oh, checkerboard, very nice. Amy, let's see yours. You made a smiley face with, is it hair or hat? Very nice. Let's see this one. Another checkerboard, very nice. Let's try this one. Oh, nice. Arush made a heart. Very cool. So we get the idea. You guys see all these different ways that we can represent now images thanks to ones and zeros or these pixels, right? So very cool things. All right, but how do we communicate with computers, right? Ultimately, these ones and zeros are not the best way for us to make things. So ultimately, we need some kind of more user-friendly way to communicate with computers in a way that feels a little bit more natural to us. That's where we get programming languages. What programming languages do you guys know? You can put it in the chat. What are some programming languages that you know? JavaScript, okay. Python, Java, Scratch, HTML, CSS, yeah. A lot of different coding languages. So all of those coding languages allow us to write code so that way we can communicate with the computer and tell the computer what to do. So we'll skip this video for now and actually just go straight into playing around with Scratch. So if you've never been on Scratch before, I just put the link in the chat. It's going to take you here. So just watch me first, and then I'll give you a second to try what I show you. So once we're here, I'm going to click on Create. Once I'm there, I now have this blank canvas. I can close out this tutorial because I don't need it. So now I see on the left a whole bunch of blocks. In the middle is where I can put my code. And then over here where this cat is where I'm going to see the result of my program. And then down here, I have some different things that I can edit as well. So if I wanted to make the cat move, for example, I can look at these blocks. For one, I can look at these blocks by color to see these different ways that these colors or what these colors represent. But I can also look at their descriptions, that these are motion blocks. I have blocks for looks. I have blocks for sound, events, control, and so forth. So if I start with an event block and find this when flag clicked, this will allow something to happen whenever I click the flag, whatever it is that I attach to it. Then I can attach move blocks, for example, to get the cat to move. So now when I click the flag, I see that the cat moves every time I click the flag. So I can also, well, we'll start there. So let's go ahead and try to see if you can make your cat move. And I also want you to, after you figure that out, see if you can figure out how to change the cat or even change the background. Ping pong, I love that game. You found how? Sid, tell me how to change the cat. Can you tell me in the chat how to change the cat? Or somebody else want to tell me? Or it might be taking a lot. There's a tiny button down below. Yes, there is a tiny button down below right here that says choose a sprite. Choose a sprite. Sprites are also what we call the characters. So if I click on choose a sprite down here, that's where I can see all the different characters that I can choose from instead of or in addition to using the cat. So I like to use the dinosaur. So I might put this dinosaur here, and then I can write code to make the dinosaur do things based off of whatever it is that I decided to do. And yes, somebody pointed out the costumes. There are different costumes that you can choose for your sprites as well. And then I can also play sounds. So maybe I might have him move and then play a sound. Let's do start sound. And yeah. Oh, I don't know if you heard the sound, but so there's a lot of different things that we can do here in Scratch. So with that, I hope that you take the chance to learn how to code and learn how to do Scratch. There's a lot of different things that you can make. I see a lot of you have made some cool images. I see more ones and zeros coming in the chat. So it looks like some of you made some more images in the pixel widget, but also you can take that and make some cool programs and games in Scratch. So I will turn it back over to our teacher, Jessie.